Thank you for joining us for Waygate Technology's TrueSight Imaging webinar. My name is Tom Ward and I'll be presenting today. In addition, my colleagues Paul Thompson and Clark Bendel will be helping me answer any questions that you may have. You may remember them for those that attended the Real 3D webinar on May 13th. Before we begin today, I want to cover a few housekeeping items. At the bottom of your screen are several application engagement tools. The tools are resizable and movable, so feel free to reposition them to get the most out of your workspace. You can expand the slide area or maximize it to full screen by clicking on the arrows in the top right corner of the slide section. If you have any questions during the webcast, you can submit them through the Q&A engagement tool. We will try to answer questions during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. We do capture and will respond to all questions. A copy of today's slide deck and additional help materials are available in the resource list. We encourage you to download any resources or links that you find useful. With that, let's get started. Let's talk about TrueSight imaging. What is it? Well, our definition, it's a blend of high-resolution image capturing and processing functions, precision optics, and a powerful suite of proprietary image transforms. This image processing and these transforms help assist inspectors when making important inspection decisions. Everything we discuss today is part of the Mentor Visual IQ video borescope system, a very powerful inspection tool used daily to evaluate the health of industrial assets all over the world. Many of the transforms I discussed today are available in a Mentor Visual IQ onboard software package we call POD. We include this POD software on our Mentor Visual IQ Analyze model, and we offer it as an option on the Touch and Inspect models. Please download and refer to the Mentor Visual IQ specification sheet for more information. It can be found on our website and is available for download in the resource section of your workspace today. In this presentation today, we'll look at several image transformation options that can increase an inspector's ability to identify or evaluate an indication. We'll start by comparing differences in pixel resolution, looking at factors that impact image brightness, and we'll discuss how adaptive noise reduction can really improve image clarity. We'll learn why dark boost is often a better option than playing with the brightness knob, and how distortion correction and inverse plus can help you check images to make sure that you're seeing everything that's available to see. We'll use high dynamic range and show how it conquers very challenging scenes, and we'll illustrate why white balancing can provide truer color rendering based on the tip selection. And lastly, we'll talk about color saturation and how that can be used to help evaluate certain applications. Now let's get started. Before we move on, I'd like to get an understanding of the years of experience that we have on the call today. Could you take a couple moments and select one of the options below? I greatly appreciate it, and thank you. As you know, a video borescope, or video probe as we call it, are used to help inspectors understand what is going on inside industrial assets. The better that that system can resolve small details, the better the chance indications are not missed. While camera or sensor resolution is an important aspect of image quality, many attributes contribute to the image produced by a video borescope, including the sensor, but also the display, lighting, processing, and optics, to name a few. Let's discuss Mentor Visual IQ's HD resolution. It has a market-leading 1.2 megapixel CCD imager and saved image resolution of 1280 by 960. We match the video recorded resolution to our XGA display, and that's 1024 by 768. But what's really great is digital zoom. Most video borescopes have digital zoom, but with this HD resolution, it becomes a much more powerful tool. you're able to resolve almost 2x what you can resolve on an SD imager without any digital zoom applied. Notice the dollar bill images on the right of the screen. You can see a huge difference in the ability to resolve details on the lower HD image, even and especially when the image is digitally zoomed. This can be very helpful in situations where it's not possible to move the camera closer to the area of interest. On the bottom right, the illustration compares the different still image sizes depending on the number of available camera sensor pixels. Having a larger image and the ability to effectively use digital zoom can be helpful in reviewing images both on and off the video borescope. Take a look at the images in this slide. This is the same image taken with an SD camera and an HD camera. Notice the difference in saved image size. We talked about that on the previous slide. If you look closely, you can also notice the increased clarity of small details in the image on the right. If we were to increase the size of the SD image, we would lose even more detail due to the pixelation that occurs when digitally zooming. As discussed earlier, image quality is comprised of multiple pieces. The same is true for brightness, a key part of image quality. Available light is only part of the story. With live video, the brightness control will adjust a brightness set point for auto gain and exposure control processing. In a still image, the brightness control digitally adds or subtracts an offset from image RGB values. In the next slide, we will examine a graphic that shows the combination of components contributing to brightness levels. This block diagram shows the pieces that make up brightness and contribute to image brightness levels. Moving from the left, we see the tip optics, camera optics, and camera sensor. Moving further right, we can see the light fibers and image harness running throughout the insertion tube. In the probe pod on the far right, you see the electronics that do the processing required to deliver an image and allow for the image transforms that can help provide increased image clarity. Our RVI business has been refining this optimization for close to 42 years. Mentor Visual IQ, this powerful processor, is the latest in this evolution and has more capability in this area than any borescope available in today's market. Here we have an example of how optical tips play a part in achieving brightness levels. There's a factor of 18x difference in brightness between the tip on the far left and the tip on the far right. This is very tied to the near depth of field, or DOF. In general, the brighter the tip, the further the near depth of field point. As an example, the gray tip is much brighter than the black tip, but trades off some near depth of field to achieve that result. The Mentor Visual IQ HD sensor will receive maximum benefit by using tips with higher brightness levels. You can find this information towards the end of the MViQ specification sheet. That document is in the resource list in your control panel. Let's take a look at how brightness is controlled on any given target for inspection. With the camera close to the target, as illustrated on the left side of this chart, we have lots of light, so short exposure and minimum gain. As the camera becomes further away, the system regulates exposure and gain to maintain brightness levels. First, exposure increases up to a maximum of 1/60th of a second, and then gain increases up to its maximum limit. Beyond that, the image begins to get darker. On the next slide, I will show how this increase in gain affects the image. As gain is increased, color and edge enhancement is reduced or suppressed. This is done to keep noise levels manageable. The top image shows a typical image created by a video borescope. The bottom image is an example we created to show what you would see if we did not reduce the sharpness and color to reduce image noise levels. Note how noisy the lower right image is. Now let's talk about long exposure. By increasing the camera's maximum exposure time, we can brighten up live images in dark places. Let's take a look at an example on the next slide. When using long exposure to brighten an image, we can restore color and sharpness. The trade-off is blurring caused by motion in the scene or from camera movement. This can be an effective way to view dark areas if motion is not an issue. Compare the blown up areas of the images above and note the difference in image clarity. That concludes our section on brightness. Let's look at some key points. Gain makes images brighter, but reduces sharpness and color. In dark scenes, long exposure can reduce gain and increase sharpness and color. For scenes that create a situation where the camera is constantly adjusting to different scenes, MViQ has a brightness lock to hold the brightness constant. This can be useful when inspecting rotating blades, as an example. Make sure the correct tip optic is chosen for the job. It can make a huge difference. Several of our brightest tip options are displayed here. Adaptive noise reduction, or ANR, averages frames to reduce visible image noise in scenes with little motion. The MViQ always applies ANR to frozen and captured images, but ANR can also be used during live image viewing, but it must be turned on in the image menu. Let's look at an example of that in a short video. I hope you noticed in the video that when we applied adaptive noise reduction, the image became much clearer. ANR is always running behind the scenes and is applied when we freeze or save an image. Take a look at the images above. The leftmost image has ANR intentionally turned off to allow a comparison. Note the blown up sections of the images above to illustrate the difference. As we conclude the section on adaptive noise reduction, let's review some key points. First, motion can impact results, so try to keep the probe still. ANR is very helpful in darker scenes where noise is more noticeable. It's always applied in frozen or saved images. However, the live version is part of our POD software package that I've discussed earlier. Before we move on, please take the time to answer the following question. If you wanted to learn more about these topics, what is the best way we could provide that content? Please select your top 3 choices. Thanks for taking the time to answer that question. Now let's discuss an image transform called Dark Boost. Dark Boost uses video processing to digitally brighten darker areas in scenes with bright foreground surfaces or glare, but it does not overexpose or degrade the contrast of uniform scenes. This can be helpful in a number of different situations, but first let's take a look at a graph that helps show what is happening behind the scenes. All cameras apply gamma correction, where the levels of darker pixels in the image are boosted digitally. This makes the images look normal to our eyes. Otherwise, the image would be very dark. Dark Boost assesses the brightness content of scenes and intelligently adjusts the gamma correction level to further increase brightness in dark areas. If you look at the curves in the graph that represent normal processing and Dark Boost processing, we see little effect in brighter areas. Look to the right side of the graph and note how the lines are very close to each other. But a dramatic effect occurs in the dark areas. See the left side of the graph. Now let's take a look at some examples to show what this looks like in an actual scene. Notice in the top image, a low contrast scene, the image is not changing with nominal brightness and Dark Boost settings of 0 and 90. In this case, Dark Boost has little effect on the scene. Remember the lines on the right side of the graph on the previous slide. The high contrast scene in the lower image set shows a constant brightness level, but with Dark Boost set at 0 in the left image and 90 in the right image, we see a very apparent difference. This difference can help give an inspector the information needed to make good inspection decisions. If you own a Mentor Visual IQ, experiment with the brightness and Dark Boost sliders and note how they impact image quality in different application scenes. Turning up brightness can increase blooming. Dark boost increases the likelihood of spotting an indication. Let's look. In the left image examples, brightness is maximized and blooming occurs. In the right examples, brightness is nominal and dark boost is maximized, providing a much better outcome. Notice how more of the heat-affected zone and weld toe is apparent in the right weld image in the top left. Also, because in stereo measurement, pixel matching is so important, dark boost can be a way to get a more measurable image. Let's look at another example on the next slide. Let's take a look at the difference using the right image when applying dark boost. First, note the panels in the combustor liner in the lower right. Take a look at how much brighter and more clear that picture is. And second, if we look at the nozzle guide vane in the upper left, take a look at the right-hand side. You really can see clearly in there and make out detail that's just very hard to make out in the left-hand image. Let's finish up dark boost by examining some key points. First, dark boost does not affect low contrast scenes. Use it when looking at welds or compressor blades or even additive parts. It can be useful when using real 3D stereo measurement on shiny surfaces, and it's also helpful when using wide area field of view tips where illumination is sometimes not uniform. Now I'd like to talk to you about distortion correction. Barrel distortion occurs when using wide-angle tip optics. This makes outside edges look curved. Distortion correction can compensate for this. Let's take a look at an example of this on a turbine blade. As we examine the turbine blade on the left, it should have straight leading and trailing edges. But on this image, they appear curved due to the optical distortion. With distortion correction applied, see the right image, we see the blade's true shape. In this case, distortion correction can help give confidence to the untrained viewer in cases where optical distortion could be seen as a bent or damaged blade. Now I want to talk about an image transform called Inverse Plus. Inverse Plus acts similar to a photographic negative. It can enhance contrast in low light or low contrast scenes. However, color is maintained when Inverse Plus is applied. Let's take a look on the next slide. Notice the fine line is more noticeable running down the center of the triangle-shaped indication in the right image that has Inverse Plus applied. See the two arrows pointing it out. Also, would you have noticed the crack in the left image circle? Always use Inverse Plus as a second opinion to the normal image when you're unsure. Please now take a moment to answer the following question. What applications give you the most trouble in creating usable inspection images or videos used for asset health decision making? Please select your top two choices. Now let's examine a still image transform. If we take multiple images that are captured with different exposure levels and combine them into one image, we have a high dynamic range image. This single HDR image can improve the visibility of both dark and light areas of the same scene. On the next few slides, we'll take a look at some examples. Adaptive noise reduction, remember when we discussed that earlier, is constantly running to produce a low noise image when needed for freeze frame or still image capture. That same A&R data is combined with multiple images captured at different brightness levels after a freeze or real 3D phase measurement capture request to generate a set of HDR images. As compared to typical HDR in a cell phone, the Mentor Visual IQ gets a much wider dynamic range within a given image. Notice the transformation of the weld image on the right side after HDR is applied. On this slide, we compare image transformation outcomes using HDR, brightness, and dark boost. The upper images show brightness at nominal, low, and high levels, which does not provide the desired outcome in any one of those scenes. The bottom left image with nominal brightness and high dark boost is better. But look at the quality of the bottom right image when using HDR. Really nice image. Take a look at this example showing how HDR can be used to brighten a darker scene. It can really be helpful in larger cavities without a lot of light. In this example, HDR is being used to brighten the background of the scene that normally would stay dark due to the camera backing down the brightness because of the foreground target. But with HDR applied, you can see both the foreground target, which is not blooming, but also see all the way down into the bottom of this particular cavity. High dynamic range is part of our previously mentioned POD software package and provides views of the standard image, an HDR light view, an HDR dark view, and an HDR nominal view. The user can enter the Views menu and choose a pre-selected HDR image to save. Also, we have recently introduced the ability to adjust the HDR nominal view, providing users with more control over their images. Take a look at how the image changes as we change the HDR level using the touchscreen slider. Let's take a look at the key points for high dynamic range imaging. First of all, you can access HDR from the Views menu on the Mentor Visual IQ for frozen or 3D PM captured images. HDR works great on shiny surfaces. It restores color and sharpness in dark scenes and can make darker background scenes brighter. A best practice is to white balance for best color rendition. If an HDR image is saved, the normal image will also be saved. And reminder, keep the probe still to achieve best results. Next, let's spend some time talking about white balancing. By adjusting relative levels of red, green, and blue, a more correct color representation is possible. Based on the numerous tip optic options available and the various lenses and illumination differences within the tips, the same scene's color can look different based on tip selection. It is a best practice to white balance after a tip change anytime inspections are performed where correct scene color is important. When the system is white balanced in the factory before shipment to a customer, it is done using head optics. In the example you see on this slide, white balancing is being performed on a stereo tip optic. It's quick and easy, and as you can see, it provides a truer color representation. Note the greenish hue in the top set of images as compared to the white balance set below. The below images represent a truer view of what the part actually looks like. Let's conclude the section on white balancing by discussing a few key points. Use the white balancing function to get true scene color rendering when various tip optics are being used. Always white balance when using UV light. By the way, the MViQ is a great tool to handle remote UV inspections when used in conjunction with our white light UV switchable light source. White balancing is quick and it's easy to perform. And also, remember, when using real 3D phase measurement, the system already recognizes the tip and a saved white balance is loaded, so additional white balancing is not required for that tip optic. A white balance will persist even after a reboot. So to change that, either go to Settings and restore default white balance, or simply white balance manually if needed. Next, we'll talk about an image transform called color saturation. Another way to change the color of an image is by adjusting the color saturation. And sometimes it is helpful and important to oversaturate an image to look for colors needed to make good inspection decisions. Color saturation in Mentor Visual IQ allows a user to adjust as desired. On the next couple slides, we can take a look at some examples of this. This example is showing how adjusting color on a weld image can change color saturation dramatically. Note the difference in the image on the right where color saturation has been turned up. In weld applications, a coupon is a known good sample to compare welds to. Inspectors use coupons to verify weld integrity, and color saturation can be used to bring out color representation in the heat-affected zone, helping ensure the weld is correctly made. By using color saturation on this blade sample, a brown, possibly burned area can be more noticeable. See the right image. If you examine the area inside the circles, the brown discoloration in the left image may have been missed by a less experienced borescoper. Color saturation can always be used as a check to ensure nothing is missed. And now let's look at some key points on the next slide to conclude our discussion on color saturation. Remember, for best results, always white balance prior to using color saturation. If when using color saturation something does not look right, try white balancing and look again. As we reach the end of this presentation, I want to remind everyone that everything I have shared today is available on the Mentor Visual IQ. Additionally, we release 2 software updates on the Mentor Visual IQ each year, updating workflows and adding new features that many times are based on input from our valued customers around the world. For those of you that use the Mentor Visual IQ today, we greatly appreciate your trust in our products. Please continue to let us know how we can improve. For those that have not yet experienced the Mentor Visual IQ and are interested in trying it out, please reach out to us and we will schedule a demonstration that suits your busy schedules. This ends the formal part of this presentation. I hope you found it useful and have learned something that can help make future inspections more consistent. We would like to thank everyone that took the time to listen today by taking time away from your busy schedules. Please continue to submit any questions you have on any of the materials we have covered today, and now we'll spend the rest of our time answering questions on those topics that we have covered.
Good morning, good afternoon, everyone. Thank you so much for taking the time to join us today for Waygate Technologies. We have Paul Thompson, Tom Ward, and Clark Bendel, who has provided the presentation portion of our session today. We are now entering into the live Q&A session where if you click on your Q&A box at the bottom of your browser screen, you should be able to input a question and we'll be able to field that question. If we come up to the top of the hour and we have open questions still remaining, we will follow up directly with you via email. So we wanted to go ahead and get started on the Q&A portion. So Paul, Tom, and Clark, one of our first questions is, Waygate Technologies is indicating industry-leading resolution. So could you take a little bit of time and compare and contrast this offering with what's available today on the market?
Yeah, thank you. That's a good question. So at the time of this presentation, we're not aware of any borescope that has more than the 1.2 million pixels with our CCD imager. I know that CMOS technology improves and is improving daily, so you're starting to see some camera systems that have up to maybe 1 million pixels that they're promoting. However, if we go back to one of the earlier slides, while imager or sensor camera resolution is very important and allows you to see more, it's really the entire system that is what is providing the image quality that allows you to see what you need to see, and really is why we are the industry leader. When you start thinking about the optical tips in both the tip and the head can, the optics in both the tip and the head can, how we transmit those signals back to the processor, how we transmit light, and then how we transmit the completed package up into the presentation or on the LCD screen. So that's really the full package that you need to consider. And so I would always advise if you're making an important decision in both purchasing a video borescope system and then trying to decide which one is better from being able to see what you need to see, make sure somebody comes in and you just take a look with your own eyes and what you're seeing there.
Great, thank you. What is the significant differential between dark boost and an inverse plus setting?
Yeah, that's a good question. Really, the difference is inverse plus is simply inverting the dark and the light areas, the bright areas and the dark areas. And it's a setting, so it's either on or it's off. There's a little bit of contrast enhancement there, where dark boost is basically looking at the dark areas and lightening those up while it's not doing anything to the areas that are already bright enough in the scene. And there's also some enhancement going on from an adjustability standpoint there. So you can use brightness, as I indicated earlier, and dark boost, and you can kind of play with those controls based on the scene that you're looking at to try to get the best outcome and the best image that you can.
Wonderful. And on the same subject, how do you white balance in UV? What are some best practices there?
Well, so white balance in general, the best practice with white balancing is if you're making a tip change and color is important to you, it just takes a couple moments to white balance. It's really very easy. It's especially important when you're doing UV, and you do it the same way. When you have your UV light coming through the probe, you simply, depending on what tip you have, go ahead and follow the white balancing process. It's really easy in Mentor Visual IQ to do that, and it's also best practice to do that each time you're doing that inspection.
Great, and could you tell us more on how dark boost and brightness help with real 3D measurement?
That's a good question. Maybe Paul Thompson, do you have anything that you'd like to say on that subject?
Dark boost and brightness, right?
As it relates to real 3D measurement.
Yeah. So this is what I would say. Those dark boost and brightness are two separate adjustments, and you'll have brightness on every Mentor Visual IQ that's available, and you'll have dark boost on the Analyze system, and it can be added as an app to the Inspect and the Touch system. So how do they help with real 3D? So the first thing I would think about is in stereo measurement and in real 3D stereo measurement with a point cloud. What is really going to help you get a very clean, clear point cloud that has valid, when I say valid, it's not a noisy or a set of XYZ points that are not truly representative of the surface. So it does that by matching the left-hand cursor placement of the operator with a pixel on the right-hand image. And if they're not precisely matched, you will not get good data. And so the first thing is you want to get a good point cloud. So adjusting brightness can help adjust the glare. Tom showed some pictures, and you'll see this after the fact in slides 23 and 24, where there were areas of that pipe weld that were glared out, and there's no way you would be able to match pixels on the left and right image in that glare. Tom also showed a picture of a power turbine blade where you cannot see the face of that blade initially until he adjusted the brightness. So brightness will help you get more measurable data in more scenes just by itself. And then dark boost, what dark boost is doing is it's looking at the lighting across the scene. It's looking at the gamma values, and it's trying to make adjustments so that the bright areas are held at bay, if you will, or at a constant level. And then the darker areas are brought to a higher level of brightness. And so using dark boost in conjunction with the brightness settings can actually give you, in some cases, even more measurable data that wasn't possible before we had the dark boost app available. Clark, I don't know if you want to add anything to that or clarify anything that I've said.
Yeah, so I think that's a good explanation, Paul. Maybe you want to touch a little bit on 3D phase as well, and or I can speak to that. It doesn't, those adjustments don't really have any impact on the projected patterns that are used to produce the 3D data when making 3D phase measurements, but they will impact the white light image that you see on the screen when you're placing cursors, or that you would see in the point cloud view. So if by using those controls you can make the indication that you're trying to measure more visible, so that you're better able to place the cursors for the measurement, it can be helpful in that way.
Okay. Thanks. Meredith, back to you.
Great. Yeah, thank you. For white balancing, using UV light, what target are you using? Or do you have any kind of recommendation on what target to use?
Hey, Clark, do you want to add some insight to that question?
Sure. Yeah, UV light is, of course, a bit different from white light in that it is monochromatic. So you can't really reproduce true colors when using UV light. So on the Mentor Visual IQ, if you have a UV system, we actually have two different sort of imaging chain settings loaded onto the system, one that's optimized for UV light and one that's optimized for the white light. And you can access those through the image menu. You would have on a UV system an additional option under that menu called imaging mode, and that can be switched between UV and white light. So in the UV mode there, you should generally get a pretty neutral color with just UV light, and then it really sort of helps the green color of fluorescing penetrant pop a bit more than what you'd have with the white light imaging mode. So when you do, you can still do a white balance with UV light, and really what that's trying to do is change any color or neutralize any color you might be getting with the UV illumination that is not the fluorescing penetrant. So in that case, you can use paper, although some papers seem to have adhesives or bonding agents that do fluoresce a little bit, so that may give you a different color than what you see on metals or other targets. So you could also potentially use a piece of neutral metal, or even whatever color metal it is that you're putting the penetrant on. If you white balance to that, it should make that color look fairly neutral in term, meaning gray to white, and then still allow the penetrant to fluoresce green and make that very visible.
Great, thank you so much. When performing an inspection sort of in the afternoon hours, there could be some differentiation in the outside light and how that impacts potential, I guess, vision of the instrument. So do you guys have any recommended best practices around using the instrumentation when you might have some afternoon light or some light disturbances in the area?
Tom, if you don't mind, I'll speak to that one.
Yeah, please.
So it's a great question, and from what I'm thinking I'm reading, this has to do with a 3D phase measurement application, and correct me if I'm wrong. And so what I wanted to say is absolutely, if you're using 3D phase versus stereo or 3D stereo, what is occurring with the 3D phase projection system is it is projecting structured light onto a surface. So the white lights turn off, the structured light fringe pattern generators start sending shadows at a very specific sinusoidally shifted rate across the scene, and the camera has to be able to see those pattern shifts across the target. So what can happen, and not only in sunlight, but also, say you're in an MRO and you're in the back shop and you have the bright fluorescent lights, if you're trying to examine a part and there is a high level of ambient light, and high is a relative number, so you have to keep in mind that most any light can have more light amplitude than the fringe patterns. So the short answer to your question is yes, it can affect 3D phase, and what it's doing is it's becoming disturbed and unavailable for the camera to see by brighter light. And so you can even get no point cloud or a very lumpy, wavy point cloud if there is ambient light, say in the afternoon on a flight line. Doesn't happen too much inside of turbines because there's no ambient light internally. It doesn't happen in pumps, pipes, valves, or motors. You won't see so much of an effect on ambient light with stereo. Yeah, I can see where you could possibly have too much light that it's causing glare, and therefore you can't get pixel pattern matching on both sides of the image. But that's typically a 3D phase structured light related phenomena that you have to compensate for by blocking the external light. And it could be as simple as a piece of paper, or I was on a flight line with some helicopter inspectors on a large turbine transmission on a helicopter, and I told them you have to block the light. They ran away and got a 50-gallon trash bag, and it worked and got exceptionally good images. So thanks for that question.
Of course. So how does the image optimizations affect the accuracy of 3D measurements as it pertains to stereo or phase?
Hey, Clark, do you want to take this one?
Sure, and I think Paul sort of hit on this one earlier as well. So they don't really have an impact on 3D phase because they're not affecting the projected structured light patterns. However, they may improve the user's ability to precisely place the cursors on the indication. So to the extent that those optimizations make the indication more visible, say it's a fine crack, maybe you use inverse plus to be able to see the ends of that crack a little better, or maybe you use HDR images to let you see areas that are shown in glare or too dark to really see the indication in the standard image. So those can help you more precisely place your cursors when you're performing 3D phase measurement. Now on stereo or real 3D stereo measurements, as Paul said, by using dark boost and or the brightness control, you can sort of optimize the brightness of the image in the areas where you want to be placing your measurement cursors, and that can help the system generate more accurate 3D data in those areas if they are either too bright or too dark in the normal image without using those knobs on the system. HDR images currently do not affect real 3D stereo point cloud generation, so it won't have an impact on the actual 3D data used for measurement, but again, it may help you more precisely place the measurement cursors in that case. So HDR will not affect the 3D data for real 3D stereo, whereas dark boost and brightness will affect that data because that processing is done on the live video and the normal captured image, which is what's used to generate that 3D data set.
Great, thank you. Is it possible to measure the surface roughness of a part?
Good question. So it's possible to measure anything as long as you understand what you're doing and you're using the technology appropriately. So with surface roughness, you would need to get very close. However, it really is going to depend on how big or what the size of the surface roughness as compared to the rest of the part. So be careful to use the technology we have built into the system that's going to guide you on whether or not you have if you're close enough to the image and whether you have collected enough data to be able to do that measurement. Take a look at your point cloud, make sure the point cloud's clean and that any noise is actually not the same size or bigger than even what you're trying to measure there. Paul or Clark, do you have any other guidance on that question?
Yeah, so I would say that if you're talking about roughness caused by erosion or corrosion, so hitting on the order of several thousandths of an inch deep, trying to measure the depth of individual pits or find the deepest of a number of pits in a field, that's something that might be appropriate for our real 3D measurement. If you're looking at something like a machine surface that may have some level of polishing applied and you're trying to determine roughness on the order of microns as a roughness gauge might be doing, then probably the Mentor Visual IQ is not going to be the right tool for that type of assessment.
Okay, thank you for that clarification. Is the distortion correction function available for live images or still images only?
That's a good question. Distortion correction, when applied, so you would go into the image setting and turn it on, is going to be applied for both live images and still images. So yes, both live and still are corrected in that situation.
Great. And how do HDR images work when doing real 3D measurements?
Yeah, good question. Paul, did you want to elaborate on that question for us?
Tom, I was a little bit distracted. I apologize for that. Clark, if you'll take that one. I was in the middle of another person asking a question on this call, Tom. Let me finish answering that, and I'll listen in also.
Sure, and this may have come in before I answered the previous question on this topic, but just to state it one more time, HDR images do not actually impact the 3D data that's used for calculating the measurement results, but it can make indications more visible and therefore can improve the placement accuracy of your measurement cursors. And in terms of documenting the indication, you often can just get a better view of that indication in your measurement images, which can be helpful as well. So I would also say that when you're making real 3D measurements, we have the fully surface point cloud view, and you can choose from the normal non-HDR image or any of the different HDR images while performing measurement, and the 3D point cloud view will be surfaced as well with that HDR image that you've chosen, along with it being shown as the 2D image for that measurement.
Great, thank you.
Thanks,
And during the presentation, there were a couple of different, there's a demonstration video, right, going through sort of using the instrumentation. Are there any other primary key points that you would like to sort of reiterate around the importance of some of those features and functions that were being outlined in the video?
Yeah. So if I understand this question correctly, on the key points in video, it sounds like you would like to see us talk more about this, and if we were to prepare some short videos and make them available either on the machine itself or provide those socially, that would be helpful. So I fully agree with that. We're actually in the process of putting together a bunch of videos that are going to talk about different functionality on Mentor Visual IQ. And we are also talking about, and it's a great question, whether or not we could have the Mentor Visual IQ pull those up as needed. The Mentor Visual IQ today, if there's a particular question you have on a section that you're in, whether it be live video or annotation or measurement, you can go into the help menu and it will recognize what state the system's in. So if you're measuring, it'll understand that you're measuring it, and it will pull up that part of the user manual so that you can quickly get to some information there. But I do agree that it would be nice to be able to pull up a short video in that same way if you're talking about something like Dark Boost as an example of that. So that's something that we are looking at doing in the future. Good question.
Yes, absolutely. And I believe as a follow-up, we once you reach out to the attendees, if there's any additional demonstrations or anything like that that need to happen, we can, of course, schedule those with the proper attendees and the proper folks. Can you talk about camera pixels and how it relates to pixels on the screen, basically during a inspection, and how does that compare to what's currently available on the market?
Yeah, so it's a good question. When we talk about sensor or camera pixels, we're talking about the capability of the camera that's part of, as I said earlier, part of the equation when you're building image quality. So all those pieces I talked about, optics, processing, and so forth. Light and the display are also pieces of that. And so the display is capable of handling only the amount of pixels that the display has. So as an example, on product, we have an XGA display, which is 1024 by 7068 or something around the neighborhood of 800,000 pixels, where we have, as I explained earlier, 1.2 million pixels as a camera sensor. So that means when you're looking at it on our display, you're not seeing the full number of pixels there or the full resolution capability of the machine. You are able, as I talked about, to use digital zoom, and you're able to zoom in, and that's going to allow you to have a better view of somebody that has maybe 440,000 pixels on their machine. However, when you save that image and pull it up, it is saving the full 1.2 million pixels from the camera resolution. Clark, anything to add there?
I think you explained that well, Tom.
Thanks. Meredith, do we have any other questions online?
Not at the moment. Paul, is there anything else you would like to cover in regards to the presentation or the video or anything else like that?
Yeah. Just a moment ago, Tom spoke about getting a better idea of what the key points are to getting a good video. And I think, Tom, you answered it very clearly from the standpoint of training videos. The thing I would tell you, if you're using a video probe and you're recording video to share with someone else, you're seeing the image happen real time, and you're processing what you're seeing and what you're doing with tactile manipulation of the camera shaft. So it's a very different experience for you seeing what's on the screen versus now you have sent that video to somebody else. And if the camera's flying around and not remaining stable on a scene for a short period of time, the recipient of that video is not going to have the same idea or get the same clear idea that you did when you were inspecting in an asset. So the idea there is during live video recording to pause on an area of interest long enough so an observer can see it. And you may also want to capture a picture at that point in time so that you can bring the remote observer's interest to that very specific part of the video. So yeah, wanted to share that with you on video with the Mentor machine.
Great, thank you so much for that additional information. We are coming to the end of our live Q&A session. I wanted to, again, thank the attendees for joining us for maximizing inspection outcomes with MViQ. We will be following up via email if we did not get to an opportunity to respond to your question. All registered attendees will be receiving a recording of this session to reference or to use later. Thank you so much again, everyone, for joining us today, and thank you, Tom, Paul, and Clark for giving us this presentation today. We really appreciate it.
Thanks, Meredith. Thanks, everyone, for joining today.